Let's talk a little bit about graphing points. The first part of this section talks about interpreting graphs, and you can see that Pam is recording the height of a bean plant, and so she's recorded the days and then the heights, and then she's made a table, and then she's come over here and taken that table and then plotted the points, and you can see as the days go, the height of the plant gets higher and higher. So if we wanted to approximate the height of the plant on day 17, you'd come across the bottom, find day 17, which is about in between. We've got 15, 16, 17, and then 18. So I would say if we approximate the height, it looks like it's about 41. And I got that because I came over here to just about where I thought 17 would be. And I went up, and that dot is just a little bit above 40, so I just estimated. It said approximate. So when did the height of the plant reach 21? So this time I'm looking on the height part. And so I'm looking at, here's 21. And then let's see, that looks like it's about day 7. Okay? You can also look at the chart. On day 7, we hit 21 inches. Okay? So that's another way to do that. So use the table and the graph from video 1, which is, I think, this graph at the top. Approximate the height of the plant on day 12. So here's day 12. So we would come up here, and I'd say it's going to be in between these two places. And we've got 10 and 13 over here. One's 29.5, one's 36. So I'd say maybe about, let's say 33. That's about in between those. Again, this is approximate. When did the height of the plant reach 44? So I'm going to come back up, and it's going to hit 44. We can look at the table. It hit 44 on day 19. So you can look at the graph to answer some of these questions. You could look at your chart to answer some of these questions. So let's look at a rectangular coordinate system, because this is what we're going to be dealing with, and I want to do some labeling of this rectangular coordinate system first. You can see when we create these two lines, we have an x-axis, and it has x on there, but I'm just going to label it x-axis and my y-axis. The x-axis is horizontal, so it runs from left to right. The y-axis runs up and down, and you can see that when they touch right here in the middle. That point is called the origin, and the ordered pair for that origin is 0, 0. Okay, when we are working with ordered pairs, which we're going to plot points in just a few minutes, you're going to have an x value and a y value. And the x value tells you how far to move left or right along the y-axis. The y value tells you how much to move up or down on the y-axis. And so the first thing we'll do is we'll move left to right along the x-axis, and then we'll move up and down along the y-axis according to what numbers we have in that ordered pair, and then we will make a dot based on that. So let's look at these definitions. In a rectangular coordinate system, two lines are drawn at right angles of each other. That's the x and y axis. The horizontal line, remember, is called the x-axis. The vertical line is called the y-axis. The x and y-axis divide the coordinate planes into four regions called, and then I didn't talk about this, but these are called quadrants. So when we're talking about quadrants, you can see I've got 4 areas: 1, 2, 3, and 4. These quadrants are numbered with Roman numerals: 1, 2, 3, and 4. And what you might get in a question as far as quadrants is, if I asked you to plot a point, what quadrant is that point in? And you would let me know 1, 2, 3, or 4. So let's do some actual plotting of points. Remember, the first value is my x value, the second value is my y value. Don't make a dot until you get to the y value. So if I've got 2, negative 4, that means I'm going to go to the right 2 places. So I'm going over to positive 2, and then I'm going to, since this is a negative 4, I'm going to go down 4. So I'm going to the right 2, down 4, and then I would make a dot right here. this would be 2, negative 4. Okay, if I'm going to do negative 4, 2, remember this is my x and this is my y, I'm going over to negative 4, and then I'm going up to 2. So this one would be negative 4, 2. Now, on your paper, you're not going to draw these lines. I'm drawing these lines to tell you the direction that I'm going, just so that it kind of helps you out a little bit. Now, when we're going to do fractions or decimals, first thing, you will not be doing fractions and decimals on a test. You may have some in homework that are random ones in homework, but we try to keep them whole numbers because it's really hard on the computer for you to guesstimate a negative 3.1. We're going to do our best because we're going to actually be just doing it by hand, but on the computer it's a lot more difficult. So the first thing I'm going to do is I'm going to change, I'd rather graph decimals than fractions, so I'm going to change this fraction to a decimal. 4 goes into 9 2 times with 1 left over, so that's 2 1/4, which would be 2.25. Now you could divide that out on a calculator and you get your 2.25. So then negative 3.1. Alright, so I'm going to go negative 2 and then about a quarter of the way between negative 2 and negative 3, and then down 1, 2, 3, and then barely over the 3. So that's kind of about right there. Negative 2.25, negative 3.1. Okay. Now, let's talk a little bit about quadrants. If I asked you where this point negative 4, 2, what quadrant that would lie in, that would be in quadrant 2. The 2, negative 4 is down here in quadrant 4. And the negative 2.25, negative 3.1 is in quadrant 3. Those are questions that I could ask you. What quadrant do those points sit in? Now, here's some interesting questions, and we can look back at these examples that we just did. Well, let's do, we're not going to worry about square roots. Let's do 0, 5. We didn't do any 0 ones, so let's do those before I answer these questions. If I've got 0, 5, remember this is my x and this is my y. And so if I've got 0 for x, we're not going to move left or right. So I'm going to sit at 0. I'm not going to move left or right, but then my y tells me to go up 5. 1, 2, 3, 4, 5. So here would be 0, 5. It does not sit in a quadrant. It sits right on the y-axis. If I have negative 3, 0, then this time I'm going to move to the left over to negative 3, and I don't move up or down because I have a 0 for the y. So negative 3, 0 would be right there, and it doesn't sit in a quadrant either. It sits right on the x-axis. So let's think about these questions at the bottom and about quadrants. So in what quadrant would both the x and y coordinates be negative? Well, let's look back at our examples. Where do you see both my x and y negative? That would be down here where I've got the negative 2.25 and the negative 3.1. And we said that sits in quadrant 3. So anytime you have two negatives for your x and y coordinates, you should be plotting it somewhere in quadrant 3. A point with a positive x coordinate and a blank y coordinate is located in quadrant 4. Well, here's quadrant 4. I have a positive x coordinate, and then look at the sign on this y coordinate. It is negative. So a negative y coordinate would be in 4. So if A and B represent non-zero real numbers, an ordered pair in the form 0, b represents a point on which axis? So look up here, our 0, 5, that would be a good example. Where did 0, 5 sit? It sat on the y-axis. An ordered pair A, 0, like my negative 3, 0, it sat on the x-axis. Alright, so here we've got dots in the graph, and I'm going to ask you for the ordered pair. in this case, it's a map of a small neighborhood where City Hall is the origin. They've marked City Hall as 00, that's the origin. 4 shops are located at points A, B, C, and D. Estimate the coordinates for each and assume the units are on city blocks. So we're counting by ones. That's why they say that it's on city blocks. And you can see the labels on my graph. Be sure you pay attention to the labels because sometimes they'll go by 2s. So be very careful when you're trying to do the points. So let's look at A. Here is A. And so I'm going to draw a line. I'm going all the way over here to, it looks like -6 to line up with the A, and then up to 4. So then A would be -6, comma, 4. To get to B, I'm going over to the 5, +5, but then I'm not moving up or down any. So that's one of those where you'd have a 0 in one of the spots, and it's going to come second because I moved I moved right 5 and up or down 0. Alright, so let's try C. C is an in-between spot, so we're going to have to kind of estimate on it. But it looks like I'm moving over to about 3.5 and down to about in between -4 and -5, so let's say -4.5. So I moved over 3.5, I'm going to put 3.5, and I moved down to -4.5. Again, on a test, we're going to have more exact like we did A and B. Alright, D sits right on a line, and it looks like I'm moving over to -2 for the X, and then I'm moving down to -7. So -2, -7 for D. Alright, so let's try some more. These are just good practice. Label the coordinates here at the bottom. You can see they did some examples here. Let's fill in C and D over here on the left example. On C, we're going over to -4, down to -4. So -4, comma, -4. And then point D, it doesn't look like I'm moving left or right at all, so that gives me a 0 for the beginning, 0 for the X coordinate, and then I'm moving down to -2, so 0, -2. So just watch your X and Y axis points, make sure you get your 0 in the right spot. Okay, so let's do A on this next example. Looks like I'm moving over to -5 and up to 1. So -5, comma, 1. Be sure you put your parentheses in these points on these ordered pairs as well. Alright, for B, I'm not moving left or right at all. So that means I have a 0 first. And then I'm moving up to the 5. So 0, 5. Now C, I almost covered up when I went to my A a while ago, but it's right here. C, I'm moving left to the -1, and then I'm not moving up or down at all. So I'm moving -1 first, but then I'm not moving up or down, so that means a 0 for the Y. Then the last one, you're moving over for D, you're moving over to 2 and down 1. So 2, comma, -1. And that's how we are plotting points. So here's just a real world example. I'll do this top one. Plotting points in an application. So the average daily temperatures for 7 days during a week in January given for Fairbanks, Alaska. Express the data as ordered pairs. This is how we use graphing. Because a lot of real world applications, it's good if you can graph them. And this could happen in the business world. It could happen in engineering. It could happen in a tech class if you're having to graph out points. So it could happen in a lot of different areas. So let's plot 1, -10. So over to 1. And then -10 would be down here. If I'm going to do 2, -8, let's keep going, over to 2, down to -8. This is nice because they're giving me nice points. They're not giving me fractions. So now I'm going to go over 3, but this time it's not negative, it's going to be up 2. So over 3, up 2. So there's a big difference between day 2 and day 3 in Fairbanks, Alaska. 4, on day 4 we're up to 7 degrees, so 4, and we're going to go up to 7 degrees, which would be about right there. Then we've got day 5, we're back down to -1, so day 5 we're back down to -1 degrees. They sure jump around in Fairbanks. 6 were at -2 degrees, so 6, -2. And then 7, -9. Back down, 7 and -9 would be right there. So that's Fairbanks, Alaska over a 7-day period. They really jump around in temperatures in Fairbanks, Alaska. This is very accurate. So there is how you plot points. Have a wonderful rest of your day.